Welcome to Eye on Academia, a podcast presented by the James G. Martin Center for Academic Renewal. The Martin Center is dedicated to the reporting and analysis of higher education events, policies, and trends. I'm Jay Shallon, the host for today and a senior fellow with the Martin Center. Today, I am delighted to welcome John Staddon. Dr. Staddon has a PhD in experimental psychology from Harvard and has taught for many years at Duke University, where he still holds the title of James B. Duke Distinguished Professor Emeritus of Psychology and Professor of Biology. He is the author of 9 books and over 200 peer-reviewed articles. In recent years, he has turned his attention to the scientific enterprise itself, culminating in his new book, Science in an Age of Unreason, published by Regnery Gateway. John, thank you for agreeing to speak with me.
Happy to be here.
I'll set things up first with a little context. Many people perceive science and its method as something that is permanent and unchanging, but that's not true. It has evolved over the ages, from basing its ultimate authority on faith to basing authority on empirical reasoning and back again. In mankind's earliest years, we used myth and tradition to explain the world around us, while utilizing whatever appeared to contribute to survival. As civilization developed, so did science, most notably under the ancient Greeks, who started to formalize science and examine the natural world empirically. The end of the Roman Empire and rise of Christianity brought a new faith-based epistemology derived from revelation. In this era, much of the empirical science of the Greeks disappeared in the West, and although philosophers were given some latitude to explore, they could not openly challenge church dogma. The reintroduction of Greek knowledge in the High Middle Ages caused a need to reconcile that knowledge with the teachings of the church, which retained ultimate authority. Modern science emerged in the 16th and 17th centuries, with Copernicus's heliocentric model challenging church orthodoxy and Francis Bacon's New Organum detailing a rough outline of the scientific method as we know it today. These discoveries forced an uneasy truce between faith and empirical reason, with each controlling its own sphere that lasted for several centuries, until, with the Darwinian revolution of the mid-1800s, reason gained the upper hand. That is how things have remained until recently. But now a strange new approach to the natural world may be poised to sweep away the reason and empiricism of the last few centuries. This approach professes to be anti-religion, while again handing scientific authority over to a moral system that at times resembles a religion. And now I'll turn to John to explain this disturbing phenomenon.
Well,
You begin your book with a discussion about the differences between facts and values. Why did you start there, and could you explain what you're talking about?
Yeah, let me say a couple of things reacting to your introduction. Science also depends on faith. It depends on a faith that there is a fixed nature to be discovered, that the laws of nature don't change capriciously. It depends on valuing, and it is a value, valuing honesty, curiosity, and so on. Okay, fact and value. David Hume was a fantastic philosopher of the 18th century, probably the greatest Enlightenment philosopher, a wonderful Scottish guy, very modest. And he pointed out that facts lead to no action by themselves. I can give you a simple example. Suppose I say men are generally speaking taller than women. Most people would say, yeah, right, okay, so what, right? But suppose I were to say that if you look at the extremes of mathematical ability, there are many more men than women. That will elicit an emotional reaction. In fact, saying just that basically contributed to Harvard President Larry Summers losing his job. But that's also a fact, exactly like the height difference. A big problem in nowadays is people have forgotten this distinction. They've forgotten that a fact is just a fact. It's either true or false. What you do about it depends on the set of values that you have. And if you feel that all men and women should be equal in every respect, you're going to get upset by some facts and not others.
Okay, well, and so this leads to a situation where, as people try to confuse the facts with their values, we've led to sort of a politicization of science in some ways. Could
Yeah,
you?
that's fair. Yeah, the little section at the beginning of the book, I made this statement that I just did, the fact value distinction and so on, and pointed out that what matters about your faith is its effect on your action. So if you look at religions, I said, look, if you look at Christianity or Mohammedanism, whatever, there are really three parts to it. One is the belief in things that you can't see, angels, God, Allah, whatever. The second is history, which is sometimes true, sometimes not, but has no direct bearing on action. But the third part is really important, and that is the values that you have, the Ten Commandments, comparable things in Sharia and so on. And what I pointed out, which raised a small amount of heat, was that science does not provide those values, so that people like secular humanists who say their values come from science are in fact wrong. Their values come from liberal philosophers like John Stuart Mill and so on. And it's quite wrong for scientists to say, well, for secular humanists, let me say, to say that their views of things like abortion, gay marriage, whatever it is, come from science. They do not. They come from a faith system that is just as scientifically unprovable as the beliefs of Christians or Muslims.
Okay, and in your book, you describe some problems in science that are kind of reaching ahead today that are not necessarily part of this political faith versus empiricism, but they're kind of intrinsic to science, or at least the world of science. Could you, like one of them you mentioned is trans science?
Well, that's not my term. I borrowed it from somebody else, but I guess the point is that science has gained a very big reputation. People trust science. Well, they did before COVID. Now, not so much. But the point is, there are some questions which you can express scientifically, but which cannot be answered scientifically. And they involve things you can't measure, experimental manipulations that ethics or practicality forbid you from doing, and so on. One example, which has caused a lot of trouble, is differences between races, blacks and whites, let's say. Are these differences genetic? Are they inherited? Well, I go through a boring length in the book about what you would need to do to actually prove this. You would have to do selective breeding experiments on cloned populations of human beings. Obviously impossible. So that's what you might call a trans science question. It can be formulated scientifically, but now, at least, we do not have the methods to answer it. And things like climate change verge on that. I just got an email mentioning that a famous Nobelist, name is Clausen, I think, just expressed his skepticism about climate change because none of the models can adequately handle cloud formation. Clouds reflect a lot of light, a lot of heat back into space and so on. And if you can't measure all that, you can't make accurate predictions from these what's called general climate models. Okay, So the question, how much is carbon dioxide affecting the global temperature, sounds like a scientific question, but since you can't actually measure global temperature, you just measure temperature in different places, and since you can't either measure or compute all of the other causal factors behind temperature, it really is a trans science question. We can guess about it, but we can't ever come to a conclusive answer.
Okay, and how about like the science as a profession also causes some problems?
Yeah, that was something I wasn't fully prepared for when I started work on the book, but the way that science has changed in the last 100 years or so is huge, and I don't think most people have any inkling about it. 100 or 150 years ago, people went into science because they were interested in science. They were interested in particular questions. You know, Faraday was interested in magnets and electricity and so on. Darwin was interested in beetles, among other things. They went in strictly because they were curious. They were curious about nature. There weren't very many scientists, really, not very many at all. But after World War II, that all changed. Applied science, applying science to the design of munitions, fighter planes, bombs, and so on, turns out to be enormously effective. And it was very effective during World War II. And that gave science a lot of kudos, a lot of kudos. A report, I think Vannevar Bush, an influential senior science bureaucrat, wrote a report called Science the Endless Frontier, like 1944 or so, which suggested that two things. One thing is when science is endless, has endless opportunities. Second, we need more scientists. And implied in all this was the idea that if you double the number of scientists, you will double the number of discoveries. Well, what that did was, and I don't want to go on too long about this, stop me if you wave your hand if you want to stop me. What that meant was that science turned from being a vocation for a relatively modest number of very smart and probably quite eccentric people into a profession. A kid in high school or college would aspire to being a scientist the way in the past he'd aspired to being a lawyer or a doctor or an accountant. So this led to a huge increase in the number of scientists. The problem is although the frontier of science may be endless, it is not infinite. At a given time, there are only a certain number of soluble problems available with the methods available. Only a small number of problems that can actually be solved at any given time. And the possibility, I can't say for certain that it's true, but the possibility is that there are now too many scientists for, firstly, for them all to be excellent. I mean, science is a meritocratic elite occupation. It's really, really hard to do good science, and only a small number of people who are capable of it. And probably quite probably are not enough solvable problems. So those are two problems. Now, what has this meant for the profession of science? Well, alongside with the idea of a profession comes a regular salary, evaluation. Somebody has to evaluate you for promotion, for the awarding of grants and so on. How can that be done? Well, if, let us say, Darwin had been evaluated by these criteria, he would have never made tenure. It took him 20 years to publish his big book, Origin of Species. Why? Because it was a very difficult problem. He had to amass a huge amount of data, much of it useless, until he had a core that made his case. That kind of science is literally impossible now. Failure is hugely punished. If you are a conscientious scientist and you do a bunch of experiments you think might work and all of them fail to work within 2 or 3 years, you can't get your grant renewed. You cannot get your grant renewed because you don't have the criterion. You haven't satisfied the criterion that is now in place. The criterion being publications. You can't publish negative results for the most part. And that's quite proper because there are a lot more negative results than positive ones. The literature would be drowned if everybody published every negative result. But what's happened is that the criterion has been publication. And so that has led to, and again, I should probably stop, but that's led to the adoption of methods, scientific methods, which guarantee a certain number of publications, but don't guarantee truth. And I could go on to the details of what that method is.
You can just give us a quick explanation of the one that you really highlighted in the book, which was the replication crisis.
Yeah, I mean, there's the standard method, which I think most people are more or less familiar with in biomedicine and in social science, is to compare groups. The theory, that is, the phenomena you are supposed to be studying concern individuals, but because the phenomena usually are not reversible, you can't study just individuals. For example, if you want to study two different methods of teaching reading, all right, you can't take a student, train him by method A, and then tell him to forget it and start over with method B. You can't do that easily with individual. With ingenuity, you can get around that. And there's historical examples of it, but it's very difficult. So the easy course is to say, well, we'll take two groups of people. We'll take two groups of people. We'll give one group method A, another group method B, and we see which one learns to read faster or better. Unfortunately, you will find in each group, some kids learn fast, other kids learn slow. Your results will be variable. So you've got to make sense of the fact that, let's say, of one group of 20 kids, 15 learned faster than the average of the other group and 5 didn't. So there'd be variability. Well, there are statistical methods for dealing with this, not very complicated. They have an interesting history we might get into. But the result has been to settle on something called the 5% criterion. In other words, if your statistics tell you this result could only have occurred by chance 5% of the time, you accept it as true. You accept it as true. The problem is if you do a little arithmetic and count things up and count all of the experiments you did that failed and so on, it turns out that if you try and replicate that with a new pair of groups, the chance of your repeating the original result is quite small. 50% maybe, 60% may fail. So the method is simply unreliable. So why do people use it? Why do people use it? Well, they use it because, given the conventions of the time, if they work hard enough, they can get a significant result enough times to publish enough papers to perhaps get promoted.
Okay, yeah, kind of like the correct results are almost baked in the cake there.
Yeah, exactly.
Um,
Even if your hypothesis is totally wrong, if you try enough times, one time out of 20, whatever, one time out of 20, it'll come up good. And you don't have to publish all the failures. So you just publish the right thing, which of course means that somebody else who comes along, he's going to pick one of the 19 failures and it's not going to replicate.
So what does the world of science look like should current trends continue?
Well, that's a very, very good question. I think what I've noticed very recently is all of these incentives, bad incentives, and pressures to publish and so on have led to an enormous number of evil effects. I mentioned in the book there are a lot of phony journals that pretend to have peer review and so on. As long as you pay to publish, you'll get something. The bureaucrats, for the most part, who look at your CV really can't tell a legit journal from one that isn't legit. So that's one bad trend. Another thing, which I've been amazed to see, I was talking to a neighbor the other day. This lady had worked with a psychiatrist as a postdoc, I think, and she recounted her experience of fraud. fraud. And I think fraud has really ballooned in the last few years. I mean, when I was working in science, 20, 30 years ago, and when I was working hardest, fraud was really a rare thing. I mean, it was inconceivable that someone would fake their data or something like that. But now, I had one chap I knew in my area. I was suspicious, and my postdocs were suspicious of him, but nobody ever did anything. I couldn't prove it for one thing. Unless you have access to the original data, it's very hard to prove fraud. But now the instances of fraud seem to be skyrocketing. And again, it's, I think, due to the bad incentives. Another example I give, which I think relates to the growing influence of what one might call anti-merit. There's a good article in the Wall Street Journal recently about merit, signed by a whole bunch of eminent scientists, which had been refused publication in the proceedings of the National Academy of Sciences, which had become totally politicized. And the reason PNAS would not publish it was because it had the word merit in the title. It didn't like the word merit. I mean, this is beyond belief, but it's true. You can read it. So there's a war on merit in favor of equity. I read recently that Bernie Sanders can't define equity, but that doesn't make it a comfortable notion. What it seems to mean is equality of results. And the Lysenko example shows one way in which this kind of system can metastasize. Trofim Lysenko was a young peasant in Soviet Russia in the 1930s, I guess, 20s and 30s. He was a biologist. He had been selected not because of merit, but because he came from the appropriate peasant stock. In other words, good Stalinists, worked on the land or whatever. And he was promoted until he became the head of Russian genetics, the head of the whole country, because he was patronized by Joseph Stalin, whose genetic expertise is not well known, but he liked Lysenko. And Lysenko had a bright idea about something he called vernalization, which was the treatment you could give to seeds which would make them bloom faster, make them grow faster. So you could have 2 harvests in a year instead of only 1. The Russian climate is very unfriendly. They're lucky to get 1 harvest sometimes. Well, Lysenko, by a mandate, by legal coercion, forced this policy on millions of peasants, and millions died because it didn't work. At the same time, one of the great geneticists of the time, Vavilov, was in a gulag and died there. So that's the result of essentially using equity or affirmative action. They didn't call it affirmative action, but that's what it was. We have to promote the peasants ahead of other people. That can be a really bad result of picking not by merit, but by extraneous, irrelevant characteristics. And I do see that now, particularly in the social sciences, hopefully not so much in the hard sciences, although the criteria for doing hard science, the passing SAT and LSAT and all of that, slowly being relaxed all over the country at elite universities. So it's something to worry about.
Yeah, I've heard one scary thing is I've heard that a lot of medical schools are ending the need for their MCAT scores.
Exactly.
And basing things on other criteria. That's opening up the world to all kinds of messes. So
I have to stop. I have to mention one thing you may not have noticed. This is in connection with climate change. I don't know if you saw on TV where a couple of environmental candidates that were being examined by Congress people, I'm not sure it was the Senate or Congress, probably Congress, were asked elementary questions about climate, okay? And the question that blew me away was, what is the concentration of carbon dioxide in the atmosphere? Now, I don't know if you know the answer to that, but then you're not a candidate for one of these things. And their answer was 5%, 8%, okay. The true answer is 0.04%. In other words, they were off by a factor of 100 and did not know it. And these are the people the administration was asking us to put in charge of environmental policy. I mean, beyond belief. Anyway, I'm stopped.
No, that's fine. So anyway, let me ask one final question. Do you see ways that these trends can be stopped or reversed? Or has the damage gone so far that the shift is inevitable?
Well, who knows? I mean, all of the social forces are pushing it forward. But I think as these scandals become more and more widely known, the fraud and so on, I spend a lot of time in the book talking about social science, which is much of which is literally nonsense. I mean, it's not empirical. They talk about things they can't measure and don't want to measure, like systemic racism and so on. They ignore causes. I mean, I'll give you a personal example. There's a systematic effort in the pseudoscientific community to simply suppress knowledge about one of the obvious causes of racial disparities, which is, cognitive ability differences. There's a conscious effort to the point that one law professor wrote to her group that she was amazed to find that a lot of people simply did not know that there was hard data showing, and this I know is a sensitive topic, showing IQ differences between different racial groups. I mean, this is either a fact or it's not a fact, but it should be acknowledged. It may have an effect, it may not have an effect. But the fact that important data are simply being suppressed, actively suppressed, and I've had this experience myself with Wikipedia and a couple of other places. This is really dangerous. It's a really, really dangerous thing. And I just hope that the political system becomes aware of the fact that we are living in a censored environment, and science will devolve into politicized pseudoscience until something is done about this. So I'm hopeful that people will come to a realization of this, and we see some symptoms of this in the skepticism about COVID. The huge problem with COVID was they attempted to suppress knowledge that they didn't agree with. I mean, by all means, say, you look at the knowledge, we've looked at it, we think the following is a reasonable policy. But that is the last thing they did. That is absolutely the last thing they did. And the only result was to confirm people's skepticism about so-called science. And that's terrible. That's terrible. Well, I think there should be a lot fewer scientists. A chap I greatly admire, a man called Terence Keeley, has written stuff for the Cato Institute. He's a Brit. He wrote a book, an excellent book many years ago called The Economic Foundations of Science. And he has argued, and I just read his argument, so I haven't studied it, that there are just too many scientists. There are just too many scientists. That's one problem. Another problem is the way in which scientists are supported. The professional model doesn't work. It works in applied science. In other words, if you're working for a car company and your mission is to design a better brake pad or something, there's the perfectly objective criterion for success. Well, the same for military science. But for basic science, that just doesn't work because you don't know, by definition, you don't know what you're looking for until you find it. I mean, it's a random trial and error kind of process. So one solution is many fewer scientists. Well, there are other sidebars here, but one thing that will strike anyone, and I haven't taught in the university for several years, but I suspect this is still true. All of the incentives in a university are on your research, very little on your teaching. I mean, scientists are in a highly competitive environment. They want to get time to work on their grants, their grant proposals, which now take almost 50% of their time, which is an absurd thing. Absurd. I was just cleaning out my office and I found I had an old grant proposal from 30 years ago, which was 70 pages, even then, when they were much smaller than they are now. So it's an absurd amount of work. I think if you reduce the number of scientists in professional roles in universities and so on, it would allow them to spend more time on their teaching, which would be a great thing. Which would be a great thing, because teaching is becoming perverted, faute de mieux. I mean, by neglect almost. Contrary forces are now entering the teaching profession. So the other thing, which I mentioned in the book, and I think is very important, all of these professional forces, the professional incentives, are greatly exacerbated by the monopoly of funding. In other words, when I was researching, I think it's true for most people now, there was really only one place I could get money to do my research. Towards the end, initially, my research was supported by the university. They had funds, and my research isn't expensive. I could get money from the university. But now, the university funds have been pushed out, one might say, displaced by external funds. That's one factor. The other factor is the external funds, at least from the government, come with goodies. They come with what's called indirect costs. So the university, although they, I'm sure, would deny it to the last, makes money out of research grants. So there's a huge force to get grants. Well, by having only one place to go, the pressures for conformity are very, very high. What you want to do is to have a little niche in which you and a handful of other buddies are dominant, so that when your grant goes to the committee, which will be 9 or 10 people, the 1 or 2 people on the committee who are experts in your area, and probably buddies, will not be unenthusiastic about your work. All it takes is just, well, interesting, and you've lost it, right? I mean, they have to be enthusiastic. So all of the incentives are to division, make your research narrower and narrower, and conform. Don't piss off anybody. I mean, if the dominant theory says one thing, you don't want to say something else, you know. So that's really inimical to the whole spirit of science. Absolutely wrong. So another thing I would suggest is reduce centralized funding. The government should not push out other sources of funding. In the old days, I can remember in England, 50 or 100 years ago, there were lots of odd little foundations and so on that supported research. They were all more or less independent and so on. That kind of diversity is really essential. Diversity of funding is really essential, and we don't have it now.
Okay, John. Well, you've certainly given us plenty of fuel for thought, and I guess I've grilled you long enough. Thanks so much for sharing your ideas with us.
Well, thanks for being interested. Appreciate it, Jay. You take care.
And you can buy John's book, Science in an Age of Unreason, at Amazon or pretty much anywhere. And it's a quick and enjoyable read for such a weighty topic. We hope you enjoyed this interview. If so, please like, follow, share, subscribe, or even say something nice about us in the comments. And if you want to see the full range of Martin Center content, please visit our website at www.jamesgmartin.center. Thank you.
Thank you.